I have a couple of boxes here from Hackerboxes. And before I continue, let me just say this is not in any way a paid advertisement or promotion or anything. I bought these both with my own money. Hackerboxes is like a subscription box thing. You pay them some amount of money, and every month you get a box with some kind of electronics project in it, usually involving some kind of microcontroller, like an Arduino or an ESP32 or who knows what. So I have two things here. I have an actual box, subscription box, but this is the first thing. This is called Surplus Surprise, and the basic idea is when they order all the PCBs and parts that they need to produce all of those boxes, there are inevitably extras that nobody uses, and so they go into a big pile and they just toss them into these surplus boxes. Here we go. And we have some kind of beer cooler immediately. Backdoors and Breaches, a card game. Jumper wires, a D20. Does that go with this? That's a GPS antenna. That's a GPS unit, a PIR, passive infrared sensor. It's a motion detector. This is just a USB light. 9 volt to standard 5.1 millimeter barrel jack. Let's see, we can guess what this is. 2 battery packs there, 2 coin cell battery holders would go there. And then we have 4 buttons. This is going to be a Simon game. That's exactly what this is. And I bet you those are supposed to be NeoPixels, right? Because we've got a 1 8-pin microcontroller to go over there, NeoPixels to control them, buttons, and the buttons in the... How are you going to get all of those buttons? You've got 4 buttons and 4 NeoPixels to drive. The NeoPixels will take 1 data pin. That's going to leave you with 4 data pins over. Yeah, you could totally do that. And I have those battery contacts or something similar that I could probably put there. I could make this. This is just, and then it's just writing the software, which I can probably go over to Hackerboxes and download whatever software they had for this. The question is, what chip are they using here? Was that a PIC or maybe an AT Tiny? There is some small text here, but I do not think that's the chip. I think that's just the order number. What goes in the center there? That's another LED? Because it's just 2 pins. I don't know. But that is an interesting project on its own to have. We've got capacitors, pin headers, LEDs, light detectors. Those are light-dependent resistors. 2 more PCBs. What do we have here? It says HDMI. So there must be some HDMI port that fits that footprint. This gives you an opportunity to interface with an HDMI port, I guess. And this... What is this going to be? Logic Analyzer version 1.0. That's interesting. And, some stickers. I actually really like this particular surplus box I got. There are projects here that I could start working on immediately. I mean, I just got to figure out what is power and ground here. And then we just find a 8-pin microcontroller that fits that footprint, and we are off and running. And then figure out what the pinout is for the LEDs. What are the common shared pins here? Because there'll be data out, data in, positive and ground, and then find out if I have any addressable through-hole RGB LEDs. Spoiler, I do. See which ones I have that fit that footprint. What is that? Is that like a programming header? This might be... You know what that is? That's a power switch. That's what that is. Very happy with that. And maybe that means I'm going to have to post a follow-up video working on one or more of those projects to see if we can recreate like that Simon game. While the surplus box only came with the PCB, I know that I have all of the components on hand to make this. And so I did a quick search And I did find that. I have, for example, here an ATtiny 85. That's going to go right there. I did ahead of time trace everything out here. I confirmed the footprint for this microcontroller matches that of an ATtiny 85. What I mean by that is we have ground on pin 4 and power on pin 8. The other pins are all I/O pins, and that matches up with an ATtiny 85. Other microcontrollers might match that footprint as well. I have an ATtiny 85. That's what I'm going to use. How did I figure out the mappings here? Well, we have two coin cells here. And the way a coin cell battery is going to fit, and I've got one in a package here, you can see it's going to slide in like that. So the positive is facing up. So the center pads here of these two footprints, these two coin cell holders, the center pads represent ground. The outside pads represent the positive side of the battery. And we can see here, if we try and get the light right, you can see that there is a trace from this pad here up to where the power switch is. So we know that the positive side of this battery is going to the power switch. We can see the negative battery contact goes over here to the positive of this one, and the negative of this one. If we follow this trace out, it goes everywhere. This is our ground for the board, this is our power for the board, and this is just putting two battery cells in series. So instead of 3 volts, this board is running off of 6 volts, which is just at the maximum of what the ATtiny 85 can take. So hopefully everything will be fine and I don't destroy anything in the process. I also mapped out the 4 buttons here on each side. Each goes to a different I/O pin on the ATtiny 85. There's also a single pin here that goes to the 4 LEDs. If we look on the back here, and we can see, hopefully, this pin here comes down all the way over to here. And this would be our first LED. And the way these work is they take power and ground, and then they have a data input pin and a data output pin. Data gets sent out to the first LED, goes into the input pin. The chip that runs that addressable LED takes the data for the first LED out of the stream of data coming through it, and then passes everything else on to the next LED, and so on and so forth. So we have 4 addressable LEDs here, all of them controlled with just a single pin. So we can detect button presses, we can control the LEDs, we have a power switch. Oh, one last thing in the middle here, we have a buzzer. This is the one thing I'm not 100% certain of right now. There are 2 types of buzzers, active and passive buzzers. Active buzzer, you just throw voltage at it, it makes a noise. Passive buzzers, you need to send it a square wave in order to have it make a sound. What buzzer should go here, I'm not sure. I could go search through all of the past projects on the Hackerboxes website, and I could see what this is from, and I could see what they did. And I could also get their code, but where's the fun in that? Anyway, so that's the breakdown of the PCB here, and as I said, I have all the parts. There is my microcontroller. I have 2 different buzzers, an active and a passive buzzer. And you can tell the difference by looking on the bottom. The active buzzer is potted. As you can see, the passive buzzer will just have a bare PCB. The addressable LEDs, I have a bunch of them. And I know that there are a couple of formats on which way they orient themselves, the pinouts, and I've been able to confirm the pinout for this matches the pinout of the addressable RGB LEDs I have. So I'm going to be able to use these to power or to act as the LEDs on the board. The battery holders, I have a ridiculous amount of different sized battery holders, and I did have a couple that perfectly match this. Buttons, I definitely have buttons that fit that footprint just fine. A couple of these actually came from the surplus box. The surplus box also had a switch that I could use for this, but it was at a right angle. And I wanted a switch that's facing straight up, and I have plenty of those as well, so I'm going to use one of my straight up switches for that. Okay, so far so good. I've got all the hardware. The next problem is programming the microcontroller. There's no programming interface here. When you put the chip down, it needs to already be programmed. Now, this ATtiny85 I have actually came out of an old Hackerbox, and I believe this did as well. This is a USB ASP programmer, and you can use this to program an ATtiny85. This is an ATtiny85 breakout board. It has headers to access all the pins on the chip. You can power it off of a USB cable, or you could wire it up. It has a voltage regulator to make sure this gets the correct voltage for it. It has a power LED to let you know the board has power, and it also has a built-in LED which you can use with your program. So before I started recording, I spent some time to work out the basic layout of the PCB, how everything is connected together to make sure I knew I had all the components for it. And I've also already programmed this ATtiny85 with a blink sketch just to make sure that this whole programming setup is going to work. Some hurdles that I ran into with this: these USB ASP devices are based around an open source project that's online. And there are a lot of clones of these types of boards. When you plug it into your computer, it doesn't see it as like a serial port. Instead, this connects as its own separate device, which means you need drivers for that. And on Windows, you need to use a utility called ZADIG or ZADIG, and configure this to use a library called WinUSB. If you don't do that, then when you go to program it, the Arduino IDE isn't going to see it, and you're not going to be able to program your device. So I had to get that set up correctly. I had to triple check these wires connecting the two together. I got a couple of them crossed over. But once the drivers were sorted and the wires were double checked, this works fine. You just plug it into the computer, stick your chip in here, hit program on the Arduino IDE, and it programs the device. And now I just want to build this thing and do a quick test code thing on this that just, cycles the LED colors or something, just to prove that it works before I sit down and try to write actual code for this. So that's what I'm going to do now. I'm going to go off and assemble this board. There's nothing especially interesting or tricky about that. The only thing I'm not sure about, again, is the buzzer. What I'm going to do is I'm going to double check the ATtiny datasheet to see what the maximum current on a single I/O pin is. And when it tells me it's going to be 10 or 20 milliamps, I'm going to put the active buzzer in and not the passive buzzer. But again, this is all, we are ways away from that. Right now it's just assemble the board and start testing. So I think I've rambled enough. I'm going to put all this stuff off to the side, and I'm going to start soldering. The board is soldered together. It took maybe, 15 minutes to put it together. Couple of things. The lead spacing on these LEDs is actually smaller than the holes on the board. If you look closely, the edge pins started cracking through the plastic material that the LEDs are inside of. I ran a diode test between the outer pins and the power pin to make sure that they were still connected internally. They still are, so I think I'm okay, even though the plastic has cracked a little bit there. It should be fine. I went with the passive buzzer. I saw a couple of YouTube videos with people using passive buzzers to do tone generation with an AT85 and driving it directly with just the I/O pin. So I'm going to give that a go, and if it doesn't work for whatever reason, well, I always have the buzzer to go back to. My next step now is to write up a quick program, nothing fancy, push a button, the respective thing lights up, and really that's all I want to do. Maybe have it go through a quick boot animation or intro animation, and then press a button, and then the LED turns on while the button is pressed. And if I can get that working, then I know that writing the rest of the program should be pretty straightforward. So that's my plan for right now. Hopefully I'm going to be done in like 30 minutes here. I just got to cook that program up. Again, it's really late. I need to go to bed. It's a work day. But for now, I got to get this done. Alright, we can see if this works together for the first time. I've programmed just a simple program. When it first power ons, all the LEDs should turn on their respective colors, stay on for 2 seconds, and then turn off. Once all the LEDs turn off, when I press a button, the LED for that button or associated with that button should turn on, and then when I release the button, it should turn off. This is the first time I'm trying this out. I've got a couple of batteries in there now, so here we go. Not a sausage. Little central pad for each of these battery holders. You're supposed to put a layer of solder over it to give it a little bump so it makes good contact with the battery. I suspect that's where things have gone wrong. Alright, let's see if this works. Oh, still nothing. Bummer, man. I mean, the problem is I can't test my code really ahead of time. I can just see that it compiles. I can't actually do much. Just trying to reseat that. What I really ought to do is create sort of, I don't know, tape these wires down so they're all staying together. So I can pull that off and attach a separate connector that goes to this socket here. Keep that plugged in there so I can keep programming it as needed. Alright, I'm going to double check my code. I might actually try sending a square wave off to the microcontroller, the buzzer, see if that does anything. Well, that was a journey. Couple of interesting things. First, you'll notice the buzzer is gone. That's because it's connected to pin 1, and pin 1 on the AT-Tiny85 is the reset pin, which is active low. And a passive buzzer is basically a speaker. It's about 20 ohms of resistance. So I was essentially pulling the reset pin to ground, keeping the AT-Tiny85 in reset, and that's why nothing was happening. That was the first issue. The second issue are my LEDs. These are addressable RGB LEDs, but the order of pins is different than what this board was designed for. The two center pins are power and ground. My LEDs have power and ground reversed from what this PCB was designed for. And in fact, I've encountered this issue before. I don't know where I got these RGB LEDs from, but they have been nothing but a pain in the butt for me because every time I try to use them, I run into this issue with the power and ground pins being reversed. I've removed the buzzer for now. I could throw the active buzzer in there, and that should be fine because there is no short to ground with an active buzzer. But I also want to research more about whether or not the AT-Tiny85 can be configured so that pin 1 does not behave as a reset. I assume there's a fuse that I can set somewhere. I just need to figure out how to program that. But for now, we're just going to go without the buzzer. This is just a demo program. There's no code yet in it, but we can see it in action. So I'll turn it on. And we have our colors for 2 seconds, and then they turn off. And now if I press a button, each color will turn on. Now if I lock the brightness here and then try to get rid of some of the light, so it works. The PCB is fine. The components that I scrounged are fine. Now I just need to, well, the buzzer issue notwithstanding, everything is okay, and now it's really down to just me sitting and writing some code for that. However, it is much later than it's supposed to be. I need to go get some sleep, so I'm going to continue this later. It's the next day. I've soldered the original passive speaker buzzer back in, and now it works. Isn't that nice? So what did I do? This board that I was plugging the ATtiny85 into to hook it up to the programmer, I noticed it also had its own little USB port here. And then I started reading up on bootloaders. Let me back up a little bit. I'm getting ahead of myself. To recap, the problem that I was having is that the passive buzzer is basically just a speaker. It's attached to pin 1, which is the reset pin. So when you connect pin 1 to ground, which is what's happening through this speaker here, the chip is kept in reset. Now, pin 1 can be used as an I/O pin, but you have to they have to program the fuses on the microcontroller to tell it to disable the reset option. And the problem with disabling the reset option is then when you go to program this thing, you need some kind of high voltage programmer, which gives a little 12 volt or 12-ish volt pulse to the chip in order to let it know, oh, it's time to program it. Whereas if you have a reset pin still working, you don't need to worry about that. That's why this and every other programmer works just fine. So to get around that, what I did is I installed a bootloader on the ATtiny85. And what the bootloader does is it sort of starts up the chip. It's a little bit of code that sits on the chip, and it will allow you to write to the flash on the chip. So it can program itself, essentially. You lose a couple of bytes of flash memory to the bootloader, but what you get back is now the ability to use that extra pin as an I/O pin. Because programming is done through the bootloader, you don't need to send any special pulses to reprogram it. And because I have a bootloader, I don't need the programmer anymore. I can just use this hooked up to a USB thing, and I can put the chip in here and program it through the bootloader with my computer. So this USB ASP device is no longer necessary. So my next step now is to figure out how to program the buzzer to get it making some tones, so then I can just have a function that I can call to have it start running a tone whenever a button is pressed, or whenever an LED lights up is probably the more correct thing to do. So yeah, this project is coming along. I've got the tone generation working now, and I've discovered something. These LEDs, have I already explained it? It's been a couple of days. And this was first put together in a fog of hubris. But I mean, we can see how the leads of the LEDs are all twisted around, and that's because the two middle leads carry power and ground. My LEDs have those reversed compared to what the PCB is expecting. So rather than try and order the correct type of LED and wait a week or two for them to arrive, I just made do with what I have, which is sort of what the whole point of this or part of what this exercise was, which is just grabbing junk that I already have and putting it to use. Anyways, these LEDs, besides having the pins swapped, which makes life a little annoying, they have another annoying characteristic that I learned. The chip that is inside these LEDs, and they claim to be WS2812s or whatever, apparently they're not. They're some counterfeit clone thing. And they require some extra time for the data to latch, for the LEDs to take their color that you tell them to. So if you try to change these colors on these LEDs too quickly, the changes or the data is missed by the LEDs. So I had to create a macro in my program that waits 400 microseconds before calling the function to display the LEDs. But whatever, it works now. And as for the generating the sound here, the ATtiny core that I'm using for this supports the Arduino tone library, so I can just call tone and set a frequency. And I looked online and got the frequencies for the different colors of the original Simon game, and it doesn't sound perfect by any means, but it's something. So here we go. And right now the code combines the frequencies, so I have a sort of silly little musical device right now. So that's all the functionality needed, the LEDs, the buttons, the sounds when you press the buttons, all of that stuff works now. So it's just a matter of writing the actual code for the game logic itself. Remove input detection while certain things are happening, that kind of thing. One button at a time, not this 2 buttons at a time thing. Although maybe that's a way to add like an advanced mode later on where it may be you need to press 3 buttons at the same time. That would certainly make things a little more interesting, wouldn't it? Yeah, this has been a nice little journey. The whole reset pin issue and having to put a bootloader on this thing, relearning using the USB ASP programmer, which I haven't used in years. Luckily, finding that I had the ATtiny85 DIP 8 package breakout board. This is crucial for all of this. This is great. I'm actually considering buying a bunch of these and maybe a couple more of these just so I can do some more ATtiny85 work, because this is just silly fun now that it's working. I've run into a little problem. I never created the rig to connect these to my programmer thingy here. I just kept moving the chip back and forth, taking it in and out of the socket every time. A few times I did remove it or insert it while power was still being provided here. Anyways, long story short, at some point this chip has been bricked. It no longer is responding, and I'm hoping I can just reprogram it. But the problem is, to reprogram it, I've been using a bootloader because I set the fuse to disable the reset pin, so normal programming with, the USB ASP here doesn't work anymore. So to program it, the first thing I have to do is figure out a way to send 12 volts to that reset pin in order to put it back into a programming mode that then I can use this thing with. So what I have to do now is remove this and bring it over to the breadboard here. And it should, in theory, be pretty straightforward. It should just be a matter of taking the connections from here and making them with jumper wires to here, but then to also include 12 volts, which I will get from my bench power supply. So 5 volts will come from here, 12 volts will come from the bench power supply, and they'll share a common ground. And that 12 volts will be governed by a transistor that will have its base connected to the reset on this programmer here. So when the programmer sends the reset command, this will get 12 volts, and that should put it into programming mode, and then hopefully I can reprogram it with the bootloader again, and we'll be back to working on developing the logic. I'm actually almost done with the game logic, I think. It has been working, and I was in the middle of tweaking the timing of things. So as the game goes on, I want it to get a little bit faster every so often. So tweaking that to something that feels good or feels natural is what I was working on at the time when I destroyed my chip here. So I'm going to wire this up, and we'll see what happens. So this is the fuse resetter. I found a sketch, an Arduino sketch online that you can program any Arduino with, I guess. And you hook it up to the ATtiny85 through some resistors and whatnot. And the important part is to have an external power source. They recommend a battery pack. I'm using my bench power supply here. I've got a NPN transistor and the 12 volts goes into there through a resistor into the reset pin on the 85. And the way this works is you upload the sketch to your Arduino Nano or whatever you have, and then when you send it anything via serial, it will send the commands to reset the fuses on the ATtiny85 using the 12 volts to trigger it to go into programming mode. And I've just done it, and it looks like it worked. The fuses should now be reset in that ATtiny85. I need to put it back into this little thing here, the breakout board for the chip, hook it back up to the USB ASP programmer, reload the bootloader, reload the code, and then I can get back to developing the logic for this thing. And it should be done within, I don't know, not much more time. Well, here it is. It's all put together, and it turns out the firmware that I was trying to program when I broke the chip might have been the good firmware. Might have been like the last iteration, because I'm really happy with how it came out so far. And there's a couple of little things to work on, but I think this is pretty good for what I've started with and where I'm at right now. I've dimmed the lights so that way you can see the LEDs a little bit better, so I'm just going to restart the whole thing. Yeah, that looks much better now. Alright, so 4 difficulty levels, 1, 2, 3, and 4. We'll just go with 1. You can see how slow it is, and that's intentional for the first level of difficulty. And I don't know if it's perceptible or not, but the gap between each display here has decreased a little bit to help speed it up as you get deeper into the game. But maybe that algorithm I came up with needs to be tweaked a little bit more. And so there is the Simon clone PCB, reverse engineered and repopulated with junk I had laying around. That's a very long title for a video. I don't know what I should really be calling this. Fun? Entertaining? It was nice. It was a good exercise. You know, there's a little mystery, a little sleuthing to figure out what the PCB was, how to, assemble it, what parts go where. A little programming exercise and writing the code for it, and learning how to reset the fuses on this thing when you accidentally brick it. It was a good project. I'm glad I did it. The code that I wrote for this is on GitHub. I will include a link to it down below if you're interested. I will also include a link to the Hackerboxes box release that originally included this, so you can see their instructions on how to put it together, and you can see the firmware, the code that they wrote for their version of Simon, or whatever we should call this, the match game or something. And it's an interesting little compare and contrast. Their code is much simpler than mine. It does more with fewer lines, but I think when I compare the two, I prefer mine more. And hey, if you're somebody who was subscribed to Hackerboxes when this one came out, and you go and figure out how to reprogram yours with mine, I would love to hear any feedback about that. But I think that is it for this video, so good luck, have fun.